So now that we know how to find simple probability, sometimes we'll need to use our counting rules to help us find the denominator of our probability fraction. So sometimes before you can find the probability, you have to count. Here's an example. A state lottery involves the random selection of 8 different numbers between 1 and 23. If you select one 8-number combination, what is the probability that it will be the winning combination? We don't see any words here that talk about the order, so we assume that there's no order, which means we're dealing with a combination of numbers. And as I said, we can't find the probability until we know the part out of the whole. The part in this case is the probability of winning, but we don't know how many possibilities there are for choosing 8 numbers. And so the first thing we have to do is find the number of possible combinations. Since we have 23 numbers, we do 23 for the n. We're going to pick 8 of them. So 23C8 for the combinations. Remember that you can go to your calculator and use the math button. Math, PRB, whoops, I forgot to type in the first number, right? So 23, then go find math, PRB, number 3, and we're choosing 8 numbers. And that gives us 490,314 combinations. There are 490,314 ways to pick your lottery numbers. And that doesn't even include different orders that you pick them in. But how many ways is there to win? One. One out of all those possibilities. So your final answer is just going to be 1 out of 490,314. We're not going to give you anything more complicated than that at this point. We're just asking you to use your skills of counting along with the skills of simple probability. So, if that made sense, pause the video before you go to the next slide, or go to the next slide, pause the video, and see if you can do this one on your own. If you've unpaused or you didn't pause to begin with, let's try it together. A club must select 6 people to serve in a committee. The committee will be selected from a list of 18 club members. If the club members are randomly selected, what is the probability that the youngest members are selected? The probability that the 6 youngest are selected. Again, if you go down here to probability, you would need to know there's one group of the 6 youngest. Doesn't matter what order we pick them in, there's just one group of them. But how many possible groups are there? So we come back up and we think, how many possible committees? Committees are almost always combinations because there's no ranking. The exception of that would be if you see a problem that says there's a chairperson or a vice chairperson or a secretary. Obviously, then you've got ranking and you go back to permutations. But in this situation, everybody seems to be equal. So we've got 18 club members, 18C6. Again, you've got your calculator, type in your 18, math, PRB, number 3, and we're choosing 6. That gives us 18,564 possible ways to choose a 6-person committee. Again, that's not even considering all the different order, but just 18,564 ways. And then, so if we come down here and we say we want to pick the 6 youngest, there's only one group of the 6 youngest out of 18,564. You have a couple problems in your homework that look remarkably like this, so use your notes as you're doing your homework.